So today we will walk through functional interface. So functional interface is features that is introduced in Java 8 with JDK 1.8. We already covered the functional interface basically at the time of covering lambda expression, but let's go through functional interface once again. Functional interface, so it is saying that in interface, function descriptor, lambda expression, method in functional interface on which signature implementation of lambda expression depend is called as functional descriptor. What it is saying, suppose we have functional interface and we are writing lambda expression for this functional interface. So here we are writing lambda expression. How to write lambda expression? First define the parameter in the parameter. So naming convention can be anything. Then this logo, then open bracket, close bracket for providing the implementation of single abstract method or body of that method. So just simply print those. In our case, name and something is, and we have to save this in the corresponding functional interface type variable. So this is how you write functional interface. Functional interface, this is how you write, and how you implementation of lambda expression depend is called functional descriptor. Method in functional interface on which basis the lambda expression depends is called as functional descriptor. What it is saying again, function in method in functional interface on which signature implementation of lambda expression depends. So this is the signature of method, which is single abstract method. So on this method signature, lambda expression is depending, and this functional descriptor, function descriptor. There is no significance use of this particular term, but you have to know because you are learning Java 8. So this particular signature, method signature of functional interface on which basis lambda expression we are going to write is going to known as function descriptor. Interface which contain only single abstract method is called as functional interface. We have seen this. This interface is containing only one single abstract method, so it is going to be called as functional interface. But we can have multiple default method, We can have multiple default method. We can have multiple static method in functional interface. So we can have number of default method, static method, but the rule to declare or to call any interface, functional interface, is that interface is only going to have single abstract method. If this interface is going to have two abstract methods, then we are not going to call this single abstract method. Then that interface is going to be called as functional interface. What else we can write in functional interface? We can write, what else we can write in interface, or let's say in functional interface. In interface we can also write static final type variable. What it is saying. And we also have to initialize this. Why? Because it is of type final. We cannot provide the value outside of this class to this variable. So that's why we must have to initialize it. We can have multiple static final type. We can have in functional interface. We can have multiple private method and multiple private static method. You can see here. You can mark the functional interface optionally with functional interface. So we can mark it as functional interface. Suppose here you can see we marked it as functional interface, and we are making mistake. We are going to provide multiple abstract method. Then this is going to give us error. Invalid functional interface annotation. Hello one is not functional interface. So it is, you can take annotation as an metadata. It is going to warn us that this hello is not a functional interface. So we cannot mark this interface as a functional interface. To make it as functional interface, there have to be only one single abstract method. Now there is everything fine. Means it is a functional interface. There is no error. Means we can have multiple static final type variables, multiple default method, multiple single abstract method, multiple default method, multiple static method, and multiple private method and multiple private static methods. That is introduced from Java 9. So we are not going through Java 9 right now. Or let's say, let's write private void show 88. Yes, you can see private methods are being taken. It is not giving any error. Still it is functional interface because we have marked functional interface. So we can see there is no error. After providing functional, inside functional interface, after providing private method, it is still okay. It is not giving any errors. So even with private static method, it is not giving error, but we are not going to focus on this because it is introduced in Java 9. We will only write multiple final static variable, multiple default method, multiple static method, but there is only going to be single abstract method to make a functional interface. What we have. Most important, built-in functional interface. Exactly like we got multiple classes, pre-built classes with Java, like string classes, wrapper classes, primitive classes, and other classes of collection frameworks. Java.util function package. Java.util function package. Inside Java.util function package, most of the functional interfaces are available. Here are the some functional interfaces named predicate in functional interface. Interface by predicate. Function. There is a functional interface with the name function. Unary operator, binary operator, by function, consumer, by consumer, supply, primitive functional interfaces, other lot of primitive functional interfaces we also have. So all these interfaces are going to have their own single abstract method. In functional interface, we can have only one abstract method that we are going to call SAM. So all these pre-built functional interfaces that are mostly available in the java.util package, java.util.function package, in all this functional interface, there are going to be single abstract method. So we have to go through what are those methods and how we can take those methods in our use. Interface with by in prefix takes two input and parameter. Basically what this line says is, let me tell you, predicate interface. Here is a predicate interface and here is a byte predicate interface, functional interface. So suppose here we have hello1 functional interface. Inside we have single abstract method. This method the interface with by in prefix, like by predicate, by consumer, by function, is going to take two parameters in their SAM, in their single abstract method. Let's move forward. let's do the code part of functional interface basically. Let's create a project. Functional interface. Write a class. Let's give a package name and let's say print. Close everything. Close others. Let's say we have multiple functional interface, pre-built functional interface. Let's say we want to work with consumer. So first we have to know that what is the methods, what are the members, what are the properties are available inside that consumer functional interface, what are the name of that single abstract method that is available in that consumer functional interface. So you can go through your command prompt and write java dot inside function we are going to get inside java.util.function package we are going to get consumer interface. Okay, yes, we got right here. You can see we are getting the members available in the consumer functional interface. So members are, here is the interface name, interface consumer is the name of interface, and the members are public abstract method void accept. So this is the single abstract method that is available inside the functional interface consumer. So what we can do, you can ignore this other members of functional interface consumer, just focus on this SAM, which is accept. So the single abstract method is named accept in the consumer functional interface. So let's bring this, let's do one thing, let's copy and paste this interface right here. Java.util must be defined in its own. Okay, no problem. Here you go. What it is saying. We can import java.util.function. Well, it is giving the java.util. Or let's don't get bothered about this, or we can say consumer. Can we import whole interface like this? Consumer, SU, consumer. Nope. So this interface is basically pre-built available with Java. We want to work with abstract, single abstract method which is accept. So for that, what we can do, we can write lambda expression as we are doing in our previous video. So accept is taking one element, let's say that can be anything because it is generics. So let's say int, it is taking int, this symbol, we are creating lambda expression, we are opening braces, closing braces to provide the implementation. Let's simply print the a, and this lambda expression have to be get stored in the corresponding functional interface type reference variable. Consumer int a, lambda expression parameter is required to be of type object. Okay, because it is here of type T, we can make it integer, and right here we can mention integer. If you know generics, then you know what I did. So what I did is basically consumer interface is having generics. We have to write here T means any data type, and exactly of that data type we are going to pass inside the method. So we are passing the integer. If we are going to remove this, but let it be there for instance. Now we got this reference variable having the lambda expression. What we are going to do, we are going to we are going to call this method of that functional interface, which is accept. That's what we are doing in lambda expression, accept. The only difference is this functional interface right here is pre-built functional interface. So we are going to call accept accept 5. Fine, but what is happening? This is not a statement. This statement is not going to work because it have to be in main method to run. So right now everything is fine. What is happening? We are providing lambda expression to provide the implementation for single abstract method of functional interface consumer. So here we got lambda expression in this reference variable by which is having lambda expression by which we are calling this method single abstract method and passing 5. So this implementation will run and 5 is going to get printed. Let's run this. 5 is right here. You can make it a string. You can pass Rahul. Rahul is going to be printed. So this is how we can work with built-in functional interfaces. Let's try to work with other functional interfaces. So here what I did, it is a functional interface. If I am going to press Control and click on consumer, then I am going to jump on this file consumer.class where the internal built-in functional interface is present. So here you can see the accept single abstract method is there. If I am going to jump in this function package in which there is going to be multiple functional interface, so I am clicking Control, but it is not working. So let's say in functional object, other functional interface that we have is let's say predicate. So how to work with predicate functional interface? So let's write it here, predicate, press Control, jump to the predicate interface. Now here you can see public interface, which is predicate functional interface. The single abstract method which is there in predicate functional interface is test. Test is taking some element and it is returning true. Means let's copy and paste it here. This is built-in functional interface. Suppose we want to work with predicate functional interface. So predicate functional interface is having one single abstract method, which is test. So what lambda expression we are going to write this for this test method? It is going to take suppose string, and what we are going to do, we have to provide implementation for this test method that is going to return type boolean. So here what we are going to do in order to provide implementation, suppose we are going to pass a at the time of calling this method test. So a is going to be string, suppose equals. If a is going to be equal Rahul, if that's how you provide the implementation. If some method is returning boolean, then you have to return boolean, and this is our logic. If a, which is going to come from argument when we are going to call this test method, if a is going to be equal to Rahul, then return true, then return true, or else return false. And return type is of course boolean, not this boolean. So what is the problem happening here? Problem is happening, we are storing this method in the consumer, but in the consumer we have method accept, and accept method is taking one value and returning nothing, but here we are returning. So it is not going to be, we are providing implementation for the test method of predicate interface. So we are going to store this lambda expression in reference variable of type predicate interface. And for that we can do generic. So here you can see, when we are going to call this, when we are going to call test method with this reference variable of type predicate, when we are going to call the test method and going to pass the string Rahul, then that test method is going to return boolean. So we can store it in boolean b, so is b. Now you can see it will give true, but if we are passing another type of values, it will be false. So what you have to remember, you have to remember the interfaces, functional interfaces, and the method inside those functional interfaces. So inside predicate functional interface, there is a single abstract method called test, which returns boolean. In consumer functional interface, there is a method called accept that returns nothing. In case of function functional interface, there is going to be one method apply, which is going to return some values. So we are going to see function also, function interface, but here let me tell you other things. So here we are providing lambda expression implementation for this test single abstract method. What we can do, we can also use the method reference to provide the implementation for this method. Suppose we are going to have any class. What is going to be the name of the class? Let's say anything A, in which we are going to have some method which is having return type of boolean. Method name is ABC, which takes suppose string, and it also what it do, it have some logic like if A equals Rahul, then it is going to return true, or else it is going to return false. So exactly this type of logic we are writing in our lambda expression. So now suppose there is a class in which there is a method that is having same return type, parameters, everything as the single abstract method of functional interface. So we are providing the single abstract method implementation as a lambda expression, but we have option of method reference. What method reference do? With method reference we create the lambda expression, but not by writing the logic by ourselves. We use the existing method logics. So what is method reference? Method reference is also a special type of lambda expression that we use to create the lambda expression by using existing method references, existing method logic. So instead of writing this logic right here for test single abstract method of functional interface predicate, what we can do, let's say here what we can do, we can write method reference. Now in method reference there are two ways: static method reference, instance method reference. In this class this method is instance method, so we have to create the object of this class, and from that object we are going to call this method. If it is, this method is going to be static, which is not here, if it is going to be static, then we can call this method directly by this class name, but here it is instance. So what we are going to do, we are going to create the object obj of A, and with that obj we are going to use this method reference delimiter symbol and call that ABC. And this ABC is going to return boolean. Let's bind it in the what is happening here. What it is saying, ABC assignment operation to complete the expression. Assignment operation A. So what is happening here? Let's remove this because these are the codes of, or else let it be here. We are not going to do this thing right here because this is, here we are doing lambda expression. We are going to do that right here. So here we are doing lambda expression. Now we are trying to do with method reference. So here we are going to write that a obj new a obj method reference delimiter abc predicate. Let's move this. Let's move this out of here, and here you can see everything is working. If this is, we are doing it with instance method reference. If we are going to make it static, then it can go with class name itself. So here we are going to, here lambda expression is getting created by the method reference, which we are storing in the reference variable of type predicate. Now with this reference variable, we can call the method of predicate, which is test. So in test, we can pass Rahul again. So it is giving false. It is giving false. What is happening right here is, let's see. It is not even running. It have to get, it is going to give, the test method is returning boolean. So now boolean true. Here it is true, and here when you provide the wrong argument, it gives false. So you can do in both ways, in lambda expression way, in functional interface, in method reference way. So let's now do some example from the notes. So here what we are doing, so in this code what we are doing, we are writing a list and we are overriding, basically we are trying to call predicate interface SAM method, which is accept. So these are the logic. If this is going to be true, then that accept method is going to return true, because that returns boolean, and if it is going to be false, then it is going to return false. And here is the filter. So filter is a user defined method which takes list and predicate. Let's write this code. So let's write this code. Functional interface class, let's say lab1. Everything is going to be in main method. What we are doing, we are going to create a list. So java.util.list new, or let's say arrays new operator array list java.util. I am writing fully qualified name. You can import this package right here. like this: import java.util, from that import everything. Then you don't have to write this thing. You have to write list interface also, but you don't have to write the fully qualified names. So whatever way you are willing to go in the list, we are going to add, suppose what we are doing here, we are adding string type. So let's make this only string can be inserted. Rahul Shyam Kumar Ronnie. Let's put nothing, let's put null. So at, let's say at two place we are providing null references at two place. So now what we are doing, we are creating a filter. Let's say filter, or let's say right here we can go through a consumer interface again. You remember the consumer interface? Here is the consumer interface. Consumer interface is taking accept method, is having accept method. Let me show you something. Just for reference, we are writing pre-built functional interface in consumer, which is consumer. We are having accept method. So what you can do, you can write implementation for this consumer interface method accept. So for that we can write lambda expression, parenthesis, it is going to take, suppose it is going to take list, or it is going to take a string, let's say string str. We are trying to provide implementation, so whatever string is going to come, we just want to print that, and we are going to store this lambda in consumer string. It is not going to return anything. Import. Okay, we have to import because it is in java.util.function package. So now what will happen, scorn.accept method, inside that if we are writing list, it is not going to take list. But what can happen, we have for each method in the collection. Let's say for each method is taking consumer. Let me show you what is happening. For each method of collection with list, with set, with map, we have for each method. We can use for each method. So for each method is here, that is taking consumer type functional interface, consumer functional interface, in which we have accept method. So when we write what for each is taking, for each is taking consumer functional interface. So we have provided the implementation and we stored it in the instance of consumer, and we are passing that consumer here. We don't have to call con dot accept method. We don't have to do this internally. Accept method will call and everything in this list is going to get printed. You can see here everything is getting printed. So when for each method is taking consumer, means when for each method of collection is taking consumer, means we can provide the lambda expression here also. So let's try. Yes, we can also provide the lambda expression for that consumer method which is accept. For this method accept, in for each is taking consumer, we can provide the reference variable having lambda expression of type consumer in the for each, or we can directly write this lambda expression. Look, here we are writing the same lambda expression. So in print, so in doesn't, we can write a string. If you have any doubts, or we can remove this string. Here you can also remove this string, so it isn't going to give you any error. So same thing in here. This same lambda expression, this is the same lambda expression. Make it inside the bracket if you want. So nothing is different. You can see here. Here it is named str. Here variable is named n, and we are printing str with SOP statement. We are printing n with SOP statement. So when a method is taking any functional interface, listen to me very carefully. When an method is taking any functional interface, then you can provide the lambda expression for that functional interface method, like I did right here, or you can implement the implementation of that single abstract method of that interface, like for each is taking consumer. So in consumer there is accept method. So for accept method we are writing the implementation here as lambda and storing it in consumer. So when a method is taking consumer, you can directly write lambda expression for that functional interfaces method, or you can provide a full implementation of that single abstract method of that functional interface and store that into the reference variable of that consumer of that functional interface which is consumer, and pass this reference variable in the method which is taking functional interface. I hope you are getting clear. Let me tell you again the same thing. For each is taking consumer functional interface. In consumer functional interface we have test method. So when for each is taking functional interface, means we have to provide the implementation of method of that functional interface. When for each is taking functional interface, which means in for each we have to provide implementation of method of consumer interface, which is accept. So to provide the implementation of that method, we can provide whole lambda expression like this in for each, or we can provide the implementation for that method explicitly at some different place and store that lambda expression in reference variable of that type of that functional interface and pass that functional interface reference variable in for each. So both are the same thing. Here this reference variable is also holding the implementation for accept method, or here we are directly providing the implementation for the accept method. Both are the same thing. Exactly same. What you can do method reference. If you have some method already available that have this logic, then you can pass that as an method reference right here. Let me show you. Suppose here I have a static method of void, because accept is void, abc1, which takes something, suppose string str, and logic is to just print that str. So the logic that we are providing in lambda is the same logic that is available inside this method. So why not use this existing method? Why to provide the lambda expression by ourselves? So let's provide the this dot for each method takes the consumer, and consumer when any method takes the consumer a functional interface, when any method that takes any functional interface, suppose it is taking for each is taking here consumer, means here we have to provide the implementation of method of consumer interface, and for that we can write the lambda expression. We can write the lambda expression somewhere else and store it into the reference variable and pass that reference variable right here, or we can use the method reference to write the lambda expression to fulfill the argument of for each, which is consumer. So what we are going to do with lab1 class, we are going to use abc1. Look here, it is also fine. What else we can do? We can store this reference method reference like lab1 abc1. This method reference is giving lambda expression, and that lambda expression is fulfilling the requirement for accept method of consumer functional interface. To save it into the consumer contour, or let's say lab1 abc1 what it is saying. What we can do, we can use generics. Here you can see now when we are calling for each is taking consumer, so we can call this reference variable which is having this method reference. So basically there is a way when a method is taking consumer, means we have to write here, we have to provide the implementation for the method of consumer, which is accept. So for that we can write lambda expression. This is first way. Second way, we can store the lambda expression in the reference variable of that type of functional interface and pass this reference variable here. So in both this lambda expression is being used. Now to fulfill the criteria of for each consumer, which for each is taking consumer, means we have to provide the implementation of method of consumer which is accept. So we can also use the method reference in order to do that. So here we have existing method that fulfill the accept method criteria. So we are using the method reference right here. Or what we can do next, we can store the method reference into the reference variable. We can store the method reference into the reference variable of type consumer interface and pass that reference variable here. So these are the 4 ways by which you can do. These are the same ways: write lambda expression or write method reference, or store the lambda expression or method reference in reference variable and pass those reference variable like this. So this is the example that we have done right here, but we didn't have gone through this example. So let's do this example also. Let me create lab 2, close others. Consumer is taking and printing. So what is happening right here is there is a class main method list, and we have provided the consumer interface method implementation. By this reference variable we can call the accept method, and let's say we have some user defined method that is here. So this method is static method which is returning list. So suppose public static, which is going to return list, and name of the method is filter, which is going to take list, or let's don't provide generic right now. It take any list, and it also take consumer. And the implementation of this method is when we are going to call, suppose this method is here. So what this method is going to do, when we are going to call, see here very carefully, this is a static method we can call in the class directly by the name filter. It is going to take list. Here we have list, we are passing list as an argument, and consumer, we have implementation for consumer. So we are going to provide the consumer. This method is taking consumer. After that, what this method is going to do when we are going to call this, so it is going to iterate the list. It is going to iterate the list. Suppose this thing list is going to iterate the list that is coming by calling this method. It is going to iterate the list, and suppose, and what we can do, let's say the consumer that is coming, with that we are going to call accept method. For that, this consumer, let's say string, what is going to happen is it is giving error because that. So inside the static method you cannot write any static method. Inside a method basically you cannot write another method. So let this static method go outside, and here co dot accept string list this list is going to get iterated. So this string, and this is also returning, or let's don't return anything void. Look, everything is good right here. Remember this example. Here there is a for each method that is pre-built method that is taking consumer, and in here we have built user defined method which is filter that is taking also consumer. So everything is same right here. At the time of calling consumer filter method, at the time of calling for each method which is taking consumer, you have to provide the implementation of method of consumer interface. So at the time of calling filter which is taking consumer interface, we have, that is here we are calling the filter method which is taking the consumer interface. We have to provide the implementation of method of consumer interface which is accept. So here we are providing the implementation as lambda, storing it in reference variable con. So we are passing that con here. We can also pass whole this lambda thing in here except of con. We can use the method reference if we have any available method with that logic. So I think you got the idea. So at previous example there is a for each method that is taking consumer. Here we have developed our own user defined method that is taking consumer, in which we are also providing the list. So here is a method, user defined method, which is a static method inside class lab2, which is taking list, which is taking consumer, and when list is going to come here, list is going to get iterated. List is going to get iterated, and what will happen? String will be the output. So what we are doing, we are getting consumer also, and in consumer we are going to get this logic. This logic is in consumer con reference variable. We are passing it in here, that is coming here with co2.accept, means when we are going to call accept with this co reference variable, this logic will run which take str. So li reference variable is basically string. It is a string right here which is going to get printed with this print statement. So when we are going to call accept, this string that we are passing here will be going to get printed through this SOP statement. Let's make it ERR, so everything will be come here in red. You can see everything is getting printed. You get the idea? but still we didn't go through this example. In this example, filter is taking predicate, not, and was the method in the predicate? We have gone through the method of predicate. That was method called test, that is returning boolean. So let's create another method. This time this method is going to be, let's say, filter 2. We are going to call this method is going to take predicate, import it. And now when predicate is come, we are knowing, and in this reference variable we are going to call test, but inside test we don't have any implementation for test method of predicate interface. So let's provide implementation. How to provide test method is in test method. If you remember, it is taking a value. Suppose it is going to take this value, open braces, close braces. If, because it is going to return boolean, so if b equals let it store it in predicate first. Then if b is going to equal to, let's say, null, then return false. Or let's say it is not, if it is going to null, not null, then it is going to return true, return false. If it is not going to return null, if b is going to null, and here we are using not operator, means when b is not going to null, then it is going to return true, or it is going to return false. Here it is going to take predicate list, suppose co, test, it is going to return true. So when it is going to return true, if this is going to be true, then if this is going to be true, then print the list. Let's call the filter 2, it is filter 2, and pass list and this. Let's don't call this method, let's call this one. Let's see what will happen. Of course some error is coming. If let's say so we have to take care of this logic right here. B equal to null. If this is going to be true, then it is going to return true, or else it is going to return false. Predicate is not going to, it is going to take string. Let's run this again. Null, null, not null, or let's say is empty. What will happen now? So here is the B in parameter. B comes right here. If B is equal to null, then return true, else return false. Okay. Rahul Sham. Here you can see it is a simple logic. If B is not going to be null, if B is not going to be null, what is the B? That is going to come right here in test. If this is not going to be null, then it is going to return true. Now, if this if statement is returning true, means this is going to li is going to get printed, in which we have a string. So Rahul, Syam, Kumar, Ronnie get printed, and null is being left behind. So you got the idea. If we are going to true is equal to null, then only null reference is going to be get printed. So that's what we did on first attempt. But okay, let's go further. So we have done this example also. Go through this. We made our own classes. We made our own user-defined method that is going to take functional interfaces. Right here, and we can call that. Let's go on another example. This is the same example to print the, like here we are creating print each method, in which we are giving list and consumer and printing by accept. This same example, list and consumer. We have optional classes. So basically we are going to cover the optional classes that is introduced from the Java 8 JDK 1.8 from the next class. So stay tuned and do practice these questions. If you don't practice, then there is not going to be any meaning of these tutorials or this PDF. Of course, this PDF is sufficient for you to learn the Java 8 features, but you have to do your work, you have to do the practices. So we are going to take look of optional classes in next class. So stay tuned.